doing live streams is always like one of those things that I don't know what I'm throwing up there. I just hope it's the right thing. Yeah, the Venture X Wi-Fi.
Awesome. Are you going to stick to Docker, or are you going to talk about Kubernetes too?
Just Docker, yeah. And like, this class will be like pretty like introductory. Just doing like some high-level Docker talk, and then build a like ECS cluster, which is like an orchestration tool within Amazon. But we won't do any like Kubernetes stuff. Doing like both of those together, I thought about doing that. That would be like pretty heavy. It wouldn't be like enough time to really dig deep into that, probably.
When you're ready to start, let me know. I'll do an intro.
Yeah, sure. I mean, probably like just hang out and get started. We probably just hang out and get started in a couple minutes.
Introduce General Assembly as well.
Yeah, go for
Most
it.
people don't know who we are. Has anyone heard of General Assembly before? You've heard. Okay. So basically, General Assembly, we've taken the trade school model for tech skills. There's a large part of the population we believe don't need to go to college. They could learn tech skills and change careers or upskill. And so we have 32 campuses around the world. When we came to Orlando, we realized a lot of people didn't know who we are. And so we're holding a lot of these workshops to help people not only learn, but know that we're here. So pay attention to some of the groups that we're going to have, or the meetings that you're all invited. So, and then we have the founder of AWS Meetup Group from Colorado, and he's going to teach us Docker.
Sweet. Yeah, I figured like, so I don't know, before we get deeper into things, like I said, just to keep like expectations, this will be like a pretty high level intro to Docker. We'll do like a bit of like using CLI, Docker CLI and stuff, and going through and creating a ECS cluster, and yeah. You're very helpful. I usually like do everything. All right, sweet. So before we go into things, does anybody use Docker or any like container services or anything like that? Well, what kind of experience do you guys have with that?
Limited local development.
Gotcha.
I wanted to get into cluster deployment and things like that, but never
Yeah.
had time and job type to play around with it in school.
Right. Yeah, we won't do any like Kates or anything like that. But what about yourself?
I build microservices with Docker.
Awesome. Like for work, or what do you guys use? Like what kind of setup do you guys have going on?
Swarm, things like that.
Okay. Yeah. Cool. Going to getting into this thing. So I'm pretty dry sense of humor, kind of awkward. Like to just like joke around with things. But I'm a cloud architect right now at PhotoBucket. I went to a school called Galvanize over in Denver, and then I got like a couple AWS certs and worked around like doing some AWS consultant at my last job, and I like to talk about AWS stuff even though I don't work for them. I'm wearing their off-printed AWS startup shirt. It's probably like the worst one they had in the bunch, but it works. So for the agenda today, like what we're doing right now, whole networking thing, knocking that out, good to go. We're going to talk about like what Docker is, like what are containers, what's an image, things like that, like some high-level concepts and things of that nature. Why would you want to use Docker? And then we'll do like a pretty basic, I don't imagine this will take the whole 2 hours, honestly. Just to run through some basic stuff. Probably do a Q&A at the end and just like talk, hang out, stuff. But do a Docker lab where we just kind of run a Docker container locally. It's going to be a node application, pretty basic, and then put it into Docker Hub and talk about like how to do things like that, how to use other images. And then we'll use Amazon ECS, which stands for Elastic Container Service, and we'll deploy a Docker container there, and then hang out at the end. So one thing, this is my first time using GIFs. I got really into them recently. I use them all the time, but ask questions. Like if you have any questions, it makes it easier for me to like kind of not get in my own thought process. I have like a hard habit of talking to myself up here, and it kind of helps I'm sitting down, we're all close, because this feels like way more comfortable. Usually I'm at a podium, like really far back with a microphone, and I feel like not super comfortable. But ask questions if you have any, and we can like hang out and make this like more collaborative and stuff, and just like kind of talk shop. This doesn't have to be like a super, you know, strict thing. Like it's 6 o'clock, have a couple of beers, hang out. So getting into things, talking about like what is Docker. So I like to think of Docker, you can go by this definition. This is like basically from the Docker website, I think. So Docker is an open source community tool designed to make it easier to create and deploy or run applications using services, using containers. But then it's like a bunch of buzzwords, like what are containers, what are these applications, what are these services, what are all these things. So like you can keep it simple and just think of Docker as like this, basically this like really easy to use tool that we have that we can take our applications and put them on different environments like rather easily and share them with each other, similar to how you would use like GitHub is how I like to think of it. Or, you know, I mean, there's much more complexities to it than that, but it's a really easy way to package up your application and then like deploy it into different environments. And also there's other ones that are used other than Docker, like Docker isn't like its own thing. I've never used any of the other ones, so I don't know them by name, but there's other tools like Docker that are also like container-based services that you can use for doing the same thing. So what is a container? So as a Docker documentation states, this is a container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one computing environment to another. Jargon, blah, blah, blah. A Docker container image is a lightweight, standalone, executable package of software. All right, you guys can read the rest of that. It's a bunch of jargon BS that we're not going to be able to understand. So basically, what we can do is we can take that knowledge and we can talk about it all. So if anybody has a good explanation of like what a container is, feel free to speak up. But basically, a container is a way that we can just like take our code, like if we have this Node application, and we just have like an Express app, and we want to run that Express app into like a production environment. We can put it into a container, which is basically this like standalone piece onto a server that has like its allocated amount of memory and resources that we have to run that exact environment. So if you think about like a server in AWS, you have like EC2 instances is what they're called. And so an EC2 instance stands for Elastic Compute Cloud. Let's make sure. Yeah. Okay. So many definitions. So basically, whenever we have an EC2 instance, it's somebody else's computer you can kind of think of in some way where they have their own data center and we're being able to tap into that using the AWS CLI or the AWS console or whatever services that we have. And then we're going to get allocated a specific amount of storage on that container or on that server. And then we're going to put a container within that little space, and that's going to be where our environment runs at. And so whenever we're using this public cloud, is what AWS is called, we have multiple different tenants, other users, using the same hardware as we are. We're just allocated a little box within that server. Does that make sense? So this is actually like more relevant to a image. So whenever we're talking about my first bullet here, so how I wanted to like talk about conceptualizing Docker is comparing it to GitHub. And whenever I say that is, we have like our image, which is basically like this set of layers, which I have a slide about it as well. So let's skip to that. So we have this like set of layers that are defined right here. And so each one of these lines right here is a layer. And so this top layer is saying that we want to take this base image, which is this, and I know this kind of sounds complex, like I'm getting into more jargon, because we're saying I got an image, but I'm calling another image. But I have this top layer that has this base image, which is saying that I have this node version 12.4, and this dash out point, which means it's like really slim, small, down, like slim version of that that's going to run fast for us. But I want to like take that and put it all into this file called a Docker file, and this is like a list of instructions or blueprints of like what is going to create this image right now. And so this image is going to be what's used to build our environment. And so this like, and we build these with Docker files. And so now we have right here, this is saying I'm going to take this node version 12.4 image, I'm going to make a directory and we're going to call it /app. So in our Docker file, we could get into the shell of it and then we could see the /app directory. And then we're going to create, or we're going to set that /app directory to be our working directory. And we're going to take all of our, if you ever use Node.js, you have a package JSON, which is a list of all your dependencies and stuff. And so we want to copy our package JSON and create a package JSON file within our app folder, within our Docker container. And then we want to install all of our packages. And then we're going to copy all of the contents right here. This line right here is going to say copy all of the contents within my project and put that into my Docker container. And then this label is like basically some metadata to say like who's maintaining it, I am. And then this command is going to be ran to start our application after we've installed everything, we set up our environment. Have any questions on that?
So
That's
that
kinda
copy
fast.
command, the first dot is the current directory and the second dot is the Docker main container.
Yeah, it's like if
Everything's path relative from your Docker file.
right, yeah. Yeah, so we're gonna take all the contents of so I'm gonna be like my working directory the /app and I'm gonna take all the contents out of my like in my application in my Visual Studio Code and put that into my Docker file. Cool. Any other questions on stuff like that? Sweet. So then, this is also one of these things that's kind of similar to GitHub. It's called Docker Hub, and similar to that is called ECR, or Elastic Container Registry. And that's the Amazon version of that. So Docker Hub is basically where we can build our image and have this like base image that says I want to have a Node app and I want to have it with these dependencies and these things and this code, and I want to store it somewhere so that any other developer could take that and be like, cool, I want to do that too. I want to have a Node app as well. Yours looks pretty dope. So then they would push it up to Docker Hub, and then this is a public place where anybody could go and see these different images and pull them down and then start having their base image. And so actually, if you look back at this right here, this Docker file, this node 12.4, this is an open image on Docker Hub. So this is a public image on Docker Hub that I went and I looked at their versions and I grabbed that image, and now I'm calling to set up my like base environment around that public image. Any questions on that? Yeah.
So, if you have a GitHub repo, you have all of your code on GitHub, and you can write that code in your own environment on your computer, install packages, make it work. You push it to GitHub, and then somebody has access to that code. They can download it onto their own personal computer in their own environment, and presumably use it, but they're going to have to install the packages themselves, among other things. So if you're trying to access somebody else's application from Docker, you would just do like a Docker pull or whatever, get it on your computer, and everything would just work, and you wouldn't have to do anything.
Yeah, pretty much. Yeah, for the most part, yeah, you would do. So if I had like that base node image or the image that I have here, and that was in Docker Hub, and you wanted to go pull that image, you would do a Docker pull, whatever the name of my image is, and then you would want to build that image on your local machine, and then you would be able to run the Docker container, and you would have the same environment that I have.
So your environment is in the repo itself.
The blueprints to create that environment are like the code, the instructions for installation, things of that
Okay,
nature.
so everything.
Yeah. Yeah. What were you saying?
I was going to say, use the cake analogy before.
What's that?
Your Docker file is a recipe for baking a cake.
Yeah.
Every cake has some standard things. You have your flour, you have your eggs, you have your milk.
Right.
That's it's your boilerplate. That's the image that you're building on top of, which is going to give you basic operating system components. On top of that, you add your source code. On top of that, you have some extra steps. Once you've added that extra ingredient that's just for your cake, then you have installing packages. That's an extra process that happens after you've added your ingredients.
Gotta ice the cake.
Now, when you get icing, decorations, editing, then you can extend this pretty far.
Right.
But your Docker file is a recipe for baking a cake based on your source code. When you build an image and push it to the registry, and this is something I'm not totally clear on, your each step in the recipe becomes a layer.
Yeah.
You know, everything is put on top until you have at the end, you're building up a cake slice, piece by piece, until you have the whole cake at the end. When you pull a recipe from Docker Hub or any other container registry or VCR, you're getting the whole cake, already made. The source code's in there, the package is ready.
Can you guys hear one?
Everything's ready. And you don't have to do any more work. You can just start up a container based on that image, and it's already running. Versus you can pull the repo from GitHub and say, follow this recipe and build a local copy of the image from scratch. So,
This sounds great.
that,
Is there any downsides to this?
no. So for me, Docker was always a response to people who didn't like full virtualization. They didn't want to have, to spin up an entire copy of Windows or an entire copy of Linux or an entire copy of the whole computer
Right.
and do that. So they said, well, what if I can fake it and just share memory, hard drive, everything inside a virtual environment?
So this is virtualization by the host OS.
What is it?
Yeah, pretty much.
Virtualization by the host OS.
Yeah. Like, I don't know, there's, I didn't build one, but
It depends how deep you want to dive, because you can share libraries, you can share libraries from the host OS into the environment.
It doesn't require any host OS to run that.
What's that?
It doesn't require any host OS to run that. You don't need to specify it.
It requires a limited one. You have to have a hypervisor which can map physical resources, input, output, memory, hard drive, network communication, things like that, into each container when it's running.
should like swatch seats. No, you're good. I appreciate it.
Yeah, right.
Yeah, this is like going on with basically what you're saying. Yeah, and it makes it like a lot faster to be able to like deploy your stuff and get it started, instead of like maybe minutes, you could go down to a few seconds and stuff. Yeah, I don't know. I didn't build this, create this, obviously, but yeah, I don't know if that helps you visualize.
Definitely.
I just always like to kick it out, so
Yeah, no, that's really good. That's a good way to put it. I wish I would have thought of that.
I heard it, so take it.
Appreciate it. Yeah, I will steal that and I will say I made that up. So basically, like continuing on from what you were saying, like why do you want to use Docker? Like, I don't know, it's a bit faster. Like you're able to allocate. You're able to like. Sorry, I'm got knee problems. So you can basically say like if I have a container and I want to have a specific amount of resources, I don't have to like have a guest OS and have like other different things. I can allocate a specific amount of memory, a specific amount of CPU CPU to my Docker container and make it more efficient, and then makes migrations a bit easier. So if I wanted to like take my environment and go from like an on-prem data center to going onto the cloud and like having a cloud environment, it'd be a little bit easier than like recreating that same on-prem environment and getting the same version of my application running and things of that nature. It's also good for like microservice architecture, so you can like break different things up. Like, let's go back to that picture. It was a good picture. VM versus container. So you can kind of see how they have like these different apps running and stuff. So this way we can like separate our different applications, but we're still running on the same like server, and we just have like different containers within that same piece of hardware. So it makes it easier for us to like decouple applications and stuff. And then also like if you want to have your developers working on the same exact code in the same environment so that we're all like doing the same thing and working together, you can Dockerize your application, and then you can have like a local development running, and then you be able to like basically be using a similar, if not the same thing that's used in production to like make sure that your code changes and stuff are the same.
When you say Dockerize an application, is that something that's going to do magically? Like, throw it out by application and it's going to split it into pieces for me?
Are you talking, well,
Maybe
Doc-
I can do it.
Yeah, wait.
So, for example, I'm working with Code for Millennium, right? They have a project that was not Docker, right? No Docker involved, and it's just like a web application, right? Data. So to Dockerize it, I found out all of its dependencies, and installed all the packages needed for that through Docker. So Docker is more like just you build that kind of isolation around that. And is that answer your question? So like I haven't even done anything with the app or Docker. I just kind of build all the dependencies.
Right, so the runtime
Environment for it.
is now reproducible.
Yeah.
Why not use something like Elastic Beanstalk or something? Like, why would you use a Docker if you can use a Beanstalk?
Why would I use Docker if I could use Beanstalk? My understanding of Beanstalk is like if I wanted to go in, and if people don't know what Beanstalk is, it's another like orchestration tool to be able to create your environment for you. And it's like good for developers. You don't have to like manage as much as the infrastructure that's there, and you can kind of go and more or less like use a GUI to configure your environment. But like, that's a good question. So if I wanted to use Docker versus Beanstalk, I would still have to go in Beanstalk and have a set of instructions that I was like clicking through and still making sure that was the same, or like having a CloudFormation template that was like scripted out. And I could do that, and sure, that's still like automation. I mean, basically what we're talking about is like a good way to automate our resources to create the same environment again, because we don't want to have discrepancies and human error involved.
With Beanstalk, can you create images?
Yeah, you can create you can create an ECS cluster with Elastic Beanstalk.
So like my application at work, I've got load balancer, 2 web servers, 2 application servers, and then the database behind them all. A Docker file for each one, sounds like? Or one Docker file for the balancer, one Docker file for the web servers.
Say your architecture again.
Load balancer, Nginx, PHP, database.
So you wouldn't have a load balance, or you wouldn't have a Docker file or anything for your load balancer. Your load balancer would be like basically like set up to listen to be like the masking for your ports to like transfer your load for your Docker containers or your Docker like your web servers and stuff, or your PHP or whatever it is. So then you would need to have a Docker file or like a Dockerized setup for your Nginx servers, your PHP, and then you had a database on the back end that would be configured through something else. You probably want to use like CloudFormation or similar orchestration tool for that. I mean, I don't know. Like, if you're, what kind of database do you have? Are you guys in an AWS environment or?
Yes. So I think we're just using MySQL.
Right. So you're like using RDS and stuff. Yeah. So I would just use RDS and I want to Dockerize that. I would just probably have but I mean.
So that's not something I would put in the Docker file.
No. You could. I mean, you could have like for local development and stuff. You could have like the same version of your MySQL database set up and like create that and Dockerize it so that you could have, this is going to go beyond the scope of this, but you could have a Docker network basically set up to where you can have your database connect to your backend connect to your front end. You can set up that all locally, so you can simulate the same environment you have in production locally, so you can basically like test things out as though that you were in production. And you could do all that with Docker. And that'd be a pretty cool use case.
And that's because they're all based off the same images?
Like all of your different environments?
Yeah.
No, you have, so like Docker has like no, they'd be all different images, but you would have a network that would, and
well, like, I mean, the same images I would run in AWS, I would run on my machine.
yeah, you could do that, yeah. Yeah, because then you could put it in the Elastic Container Registry and you could just pull down that image, and then you could build that image on your own machine, and we'll do that, and then you would be able to run that on your own machine. But you would want to probably create your own environment, because and you know, like, you know, my own disclaimer here is I don't have enough knowledge to say like what the best use case would be for your database, but you could create that same environment that you have in AWS in your Docker files, and then use most of those Docker files. You could have like, okay, so if you did this, you would have a big repository set up, let's say everything's coupled together and you built a monolith. But let's say that you had a database layer and you had a web layer and you had a backend like API layer. And then you had a Docker file for your database and you had a Docker file for your your web tier and your API layer, and then you had a like Docker Compose setup or something like that, to where you'd be able to connect all three of these different resources together, and you could use each individual Docker file to create its own ECR image, and then create your own cluster, and then have like your different containers running for your three different layers of your environment. But if you're using RDS, I wouldn't like put it into a Docker container. I'd use RDS. That's a bit like multiple layers beyond this course, but yeah. Does that kind of answer your question?
Yeah.
Just like for my own curiosity, like what are you guys using on the Nginx side? Like,
Just as a proxy, application proxy.
maybe what is it like? You have a front end framework or?
Oh, the application itself is written in Laravel.
Oh, okay. Never mind. I don't
Yeah.
know Laravel or PHP, so.
Basically, PHP is running.
So it's all server side rendered, yeah. Gotcha. Okay. I was gonna say like, I would advise moving that to like decoupling it to like an S3 bucket using Amplify or something. But if you have it all server side rendering, never mind.
Yeah, we have a model. It's not
Fair
much.
enough. Any questions before we like go deeper into the lab and stuff? I feel like I had something else to say a minute ago. I forgot. Oh, any questions first? I just remembered. Yeah.
So, if you're saying that you could have an application, like an on-site application, and Docker would be a tool that you could use to aid you in migrating everything to the cloud, like you'd have your on-site everything, and you could use Docker as a tool to configure things a certain way, and then move it to AWS. That's possible.
Well, so I mean, like, of course, there's a bunch of caveats and things like that. It's not going to be as easy as just like saying Docker build, put in the ECR, and create a cluster. Like, you know, you're going to have, if you have like, you know, your database tier and things like that, you're going to have like networking configuration, security groups to set up, and you're going to have like a bunch of different like environmental things to set up. But as far as like taking your application, running it on a server, and just an application, and it's probably not going to work the same way because you're going to have to connect your database and do things like that. Let's say you had a front end app and you had it running on-prem on some server, and it was a React app, for whatever reason you had it running on-prem, and you wanted to Dockerize that, put it on an ECS cluster, then in that case, yeah, it would be like taking it and putting it there. Or if you had like a, let's say a Node Express API, and you had a MongoDB, Mongo database set up for your database tier, and that was using like Mongo Atlas. You know, you changed some VPC configuration, so you had like VPC configuring, that's just something you have to do for Mongo, but then you could basically like Dockerize a Node API, put it in there, and like, you know, there's things that you could do that with, but for the most part, like there's more configuration to it than just that. But it's definitely like an easier way than, you know, trying to set up an auto-scaling group on EC2 instances and downloading your web server onto there and having all of that configuration set up. Like, yeah, there's a lot less involved. You still have to set up the database and all that stuff. Does that answer your question? Sweet. Any other questions? Cool. So one thing I guess I didn't add was like best practices. Just like one thing I have on the top of my head is, so whenever you're writing these Docker files, a good best practice is, like, you see how I have this copy file here, or this copy line here, and not like maybe on line 5. The reason for that is so that whenever I do this npm stall and stuff, if I had my copy file up here, then it would like notice a change here, and then it would re-execute. And so basically, like, Docker's smart enough to have a memory of the old functions I ran and like know if there's any changes and things. And so if I had like changes to my code, then I wouldn't have to like rerun everything. I could just like rerun my copy and stuff, and it would be able to like run that for me. And so like you reduce the amount of times that like everything is reran if you think about how you organize your Docker files. Basically what I'm saying. So
I did have a question about
yeah.
building an image. If you have less layers, would that make the image smaller?
I don't know. Let's Google that. Let's see, Docker image best practices. So I honestly don't know the answer to that question.
don't wanna derail your presentation.
No, no, you're good. I mean, do you guys feel like this is worth like looking up? I mean, I'd be learning something.
It depends on what you put into it. You could have one command that adds hundreds of gigs to your image.
What if you have a requirement to have a smaller image than the one you built 5 minutes ago? How would you go about doing that? Make it into less layers or how do you?
So the number of layers is not necessarily important.
But it can be.
So what I've seen before in other Docker files that I've looked at is if you, like there are a lot of Docker files where you install it and there's just like a couple of commands built in. So the first thing you have to do is sync your app repository. You know, get a list of packages I can install on this operating system and then install like 2 or 3 of them. But there's a whole bunch of junk that got downloaded, you know, a list of all the packages you could install. So you clean that out, and then that shrinks the size of your Docker. So you'll see a lot of Docker files that basically install something, you know, install a bunch of stuff to compile their own code, and then get rid of the compiler. But the end result, like the image itself, is basically just a zip file of the hard drive that you need to run the whole thing. If you have anything in there you don't need to run your program, take it out. But
Here's like a Stack Overflow answer for you. Basically, like similar to what I was saying, like your Docker file has like different layers that are cached, and you don't want to like order your Docker file in a way where you're having to like repeat things that were already cached that you didn't need to repeat, and then that can add like bloat to your application. But I need to bring you around with me. You were super helpful, so I can go Google things.
yeah.
Okay, so
You want the cake analogy for that one? For the build time? If you're gonna change the topping on the cake, that's easy. You take the old one off and put the new one on. That's a step at the end of your Docker file. Super easy, right? Change the candles, it's a new birthday. If you want to change and use organic eggs instead of regular store eggs, well, you have to start all over. You have to start at the bottom, add the flour, add the eggs, add the milk, all your ingredients, install the packages. Right. So the very last thing you do is put your application inside and install your packages, then that's the only thing you have to redo when you're rebuilding it.
he's building a cheap cake. Probably tastes terrible. All right, so okay, so I like to get a little bit more like hands-on and like show some stuff, and I do everything live. So if you guys want to follow along with me, you can. If you guys do want to follow along, you're not going to be on the Wi-Fi. Like, is anybody that wants to follow along not on the Wi-Fi? All good. So if you haven't already, let's install Docker Desktop. Never installed anything on the fly, so hopefully this works well.
I actually have a quick question about that.
Yeah.
I tried installing it a few days ago when I was looking at the Career Experts course, and apparently Lead Windows 10 Pro.
Oh, you're on a Windows machine. Oh, I can't help.
So I have no idea. Do you know if there's like maybe like spin up an EC2 that already has Docker? Yes.
Oh, yeah.
There's another option, you can't,
Did you get it through? I
yeah,
got it
but
from
I
here.
think you have to just run it with your command line.
I'll look it up.
There's another option, but
Yeah, I'm not 100% sure with Windows installs and stuff. I pretty much have like zero knowledge with it. There might be a like Amazon image that already has Docker installed. I don't know. But for Mac, like I'm gonna run through how you would install things with Mac. So if you went and Googled Docker Desktop install, they have a link that's Docker Desktop for Mac and Windows. So I can just hit Docker Desktop for Mac and Windows button. And then they have the Docker Desktop for Mac. Install that. Hopefully that doesn't take multiple minutes. But then we can start writing some commands and stuff. Oh, also, I guess what we can do in the meantime is I have this repo here, the Docker on AWS repo that we're going to use. If you haven't cloned that already, we're going to clone that now. Sweet. Okay, cool. So I've got this cloned. Well, I just write everything in here. Can you guys see that? Is it kind of bright? Sweet. I'll wait a minute for this to install. Any questions before we go deeper into this and get this thing installed? You said you interned at AWS? How did that go?
I loved it. I did finance, so I'm not like super, like I don't know about this too much.
I did demand generation, so I did sales. So I worked with a lot of solutions architects and going over cloud architecture. And we also did, so I finished my cloud practitioner certification and I'm working on my ASA.
Yeah, nice. What are you using to like train for that?
GitHub group.
Yeah, good choice. Yeah, they just bought Linux Academy, so that's like a pretty big deal.
Yeah.
And I would recommend like before I'm not very good at taking tests and stuff, so I used WizLabs, just like a quick pivot. If you guys ever want to get like AWS certified or whatever, WizLabs. So this is like a really cool way where you can like go buy practice tests, and I would highly recommend taking practice tests. And also their practice tests, if you get a question wrong or right, they have an explanation with documentation and like links to the documentation within the questions. I feel like I almost learned more taking these tests than I did at Econ Guru for some things.
So the WizLabs is just a practice test, right? There's no lecture above. They're both there.
Yeah, I don't know. I've never used the lectures, but the practice tests are like $20, $19.99. But then you get like 6 or 7 of them. They're definitely worth it. Like, I mean, a test's $150, but it's like great for your career. So. Okay, so now I've got Docker Desktop installed. My battery's getting pretty low. Let's see if I can get set up with a charger here. Okay, say I want to download it. Give me 1 second. Get plugged in. Otherwise, you're in the danger zone. Okay, so sweet. So everybody have like Docker installed now, and for the most part good to go? Cool. So now I've got Docker installed. Out here at the top you can see it running. If you haven't used Docker before, I guess it's probably gonna make you sign in, so let's see if I could sign out and do that. And a Docker ID is the same as like your username. So then if you haven't created one, you have to create one at Docker Hub. So then you can just sign in, and then it's going to be like, cool, you're signed in. You can also run like Kubernetes and stuff in here. Like Docker Desktop's pretty awesome. But to make sure that we downloaded Docker correctly, we can run like Docker info. We should see a bunch of stuff about Docker and see what else is going on. And then we could run our first image. So you could run Docker run hello - world. So it says, first thing it says is unable to find image, hello world latest. And so how this is set up is, in this command, I have to call Docker because we're using the Docker CLI. I'm trying to run the hello world image. So this is the name of the image. And then here you can see hello world colon latest. So this colon and whatever's after the colon is called like a tag. Or it's called a version. So this is your, had to think there for a second. So this is your image name, and then this is the version or whatever you want to call it. And so we've got the latest, that's what it names it by default. And so it says it's unable to find that image locally, so it's going to be pulling that from Docker Hub. So then we pulled the image, it's all successful. We get the output saying hello from Docker, good to go. So then it says like this is how we were able to get this. So it says the step number 1 was we contacted the Docker daemon. Docker daemon didn't have it, so then we pulled it, hello world image from Docker Hub. Then Docker daemon created the new container, which we could see Docker images, yeah. So we could see, oh man, I meant to delete this. Right here is our hello world. And then Docker daemon streamed the output to the Docker client. So then now we're able to see this hello from Docker. So then some other like ambitious stuff we could do is run this. We're not going to do that, but what I'm going to do, actually you don't see this, skip ahead, it's a couple commands, but never mind, we'll just go with it. So right here what this is different images that I have. So to see your different images on your machine, you could run Docker images. And so I can see this is the name of my image, and then I can see like how long ago it was created, how big it is, the different tag. Okay, so I had that name correct, and then my image ID. And so I've got these different ones, and this is the one that we just ran. Any questions on like the basics of like pulling or like running an image and being able to see your different images and stuff? Okay, cool. So to talk about like this application before we do more Docker stuff, we have just an app.js, which is really basic. All it does is render this public site, which I bootstrapped from a CodeStar repository from AWS. So it just is going to run that static site. So if we ran that, we could do like an npm install, and then we could do node app.js, go to localhost, and then we could see this is our application that we're going to put into Docker Hub and we're going to be playing around with. So this is me running it just with like a node command, not using Docker at all. So then we could go into our Docker file and we can see like what we talked about earlier. We talked about the structure of how this is set up. We have like our base image, we're making a directory. This is all within Docker, within our container that's going to be running. We're going to set the /app directory to our working directory, copying our package JSON with all of our dependencies, which I'm using Express. We're going to install those dependencies, copy all of the code into our Docker container, add like little metadata, and then we're going to run the command node.js. We can start our app, just how I ran it right now. Any questions on like how that works? Cool. So now what we would need to do is, if you had the repo cloned and you wanted to build the Docker image and have it so that we could run on our own machines, you could run docker build-t, and we're going to call this docker-on-aws. I would call it that as well because it would just make it easier for running these other commands that I have pre-baked in here. Also, if you look at the repository, there's a README that we're going to be kind of following along with, kind of loosely, but there's a bunch of the commands in here I'll be referencing that we're going to be using to run our different run our application. So then I can run this. So this docker build-t Docker on AWS is going to build our current directory, because I've got the dot, and then we've got this -t, which is going to give it a name, give it a tag to say like, hey, we're going to call this Docker on AWS. We ran that. Mine is going to execute rather quickly because I've already built it and nothing has changed, so it just basically mostly did nothing because everything has been cached. So then I can see like Docker images. And then right here, we have this Docker on AWS. It was created 12 seconds ago. Great. It's 82.8 megabytes. So now what we need to do is run it. So we had our node application running a moment ago, so we want to get that running, but in Docker. So we could do Docker run. We could do like a dash dash name, give it a name. We could call it like a Orlando node app or something. And then we could do a dash. Let's do a dash dash rm. Actually, let's not. We'll do that on the next one. Talk about that. So we'll do a dash p for our ports. So this is going to be our port that our Docker container is opening up for us, and then our port that this is going to be the one that our application is running on, and this is the one that Docker is opening up for us. And then we're going to put the name of our Docker container. So it's going to be Docker or our Docker image on AWS. So now it's listening on port 80. So then I could go back and make sure that that's correct. And then we've got enter to Docker, and this is coming from our Docker container. Any questions on that? So then if I wanted to see the different images that are running right now, I could run Docker PS or Docker container ls. Either one, both do the same thing. So we'll run Docker, hold on, let me not have this be crazy. So Docker PS. So basically, this looks terrible how big it is, or how small it is. All right, cool. That looks a little bit better. So we've got our Docker ID, we've got our image, got our like entry point command. This is like pretty much default, how long ago it was created, and then our port. So this is saying that we have basically open to the world, so we can run it on localhost. We can go to 0.0.0.0, and it's going to be like sending that traffic to port 80, and then our name is Orlando Node App. So we could stop this container and talk about like some different commands, or we could like go into the shell of it. I think the command to do that is docker exec, and so if we wanted to go into the shell to like see the different directories and stuff, we do docker exec dash IT for interactive, and then the name of it is docker dash on AWS, and then sh Orlando Node App. There we go. Okay, so now we're in the /app folder. This is within our Docker container that's running on our computer. So we can do an ls, and we see we have the same, basically the same exact thing that we had right here. And then, you know, I could like even run node on here and be like, run some regular node commands and stuff. So that's pretty cool. We can do some things like that. If you wanted to see like different commands that Docker has, you could do docker -- help. There's tons. So these are the management commands. These are what mostly you're going to be wanting to use, stuff like this. And so you see we have the network we were talking about earlier. So if we wanted to see like different commands within this to see like, okay, cool, we got Docker image, but how do I use that? Like if I ran Docker image, it's probably going to be like, well, that's not a proper command, we need something else. You could run docker image -- help, and this will help direct you. They did the same thing, but this will help direct you to say like, cool, what do I want to do? What can I see? Things like that. And so this is like a good way to like help you navigate through like different commands that you need to run, such like we just ran docker build, and docker images is the same as docker image as ls. It's just a little bit shorthand, you know, things like that. So to stop our application, how I was able to hit like Command C earlier, I can't do that here, so I need to stop my application. If you didn't name it, you would grab the, let's keep it in here. So docker container ls. So we've got our container running. So if I didn't give it a name, which is optional, I would grab this container ID and stop it. But since we gave it a name, I could do docker stop Orlando node app. take a second, and we can watch right here. This is going to clear out.
Why doesn't it respond to full sleep?
I honestly don't know. Like if you were to run it with like if you had NodeMon installed, which is like the development. If you've ever used Node, it's like the way that I could run in development my application and then make changes to my code, and then it would automatically like hot reload for me. And if I ran like my command as NodeMon app.js and had like it installed up here somewhere, it would allow me to do a Control C. I don't have a good answer for why it doesn't let me do that with that, honestly. Because yeah, it is kind of like a pain to go and open another terminal and then hit like stop. But so now we can see it outputted the name of our container, and we can see that it stopped. But if we go Docker images, we see our image is still there, which is good. But what about our container? So we can run docker container ls-a, and then we see our different ones that we'd ran that are still around, but they're not running right now. And so we could get rid of these different containers. I think it's docker container rm Orlando node app. Yeah. And then docker container ls-a. Yep, so then we got rid of that Orlando node app. I don't memorize every single command. That's why I'm like sounding unsure of myself. Usually Google's your friend. Can't remember everything. But so now we can see that we have just that hello world one. This one is not running. This is just showing the different containers that we have built that we could easily run again. Any questions on any of those commands? Okay. So cool. So we were able to have this node application. We ran it as though it were just a regular node application, and then we were able to build it, put it into a container, run the container, see it's basically doing the same exact thing. We were able to check to see our different containers running, see the different help commands, stop our container, and things like that. So if just to show you like again running a container. So if I didn't want to, sorry, I have like a bad habit of using that. If we didn't want to go back and like run this again, to go back and like clean up after ourselves, what we could do is do docker, docker run, and we don't have to give it a name, that's optional. So we can just do docker run -rm-p 80 docker on AWS. Cool, and then let's say docker ps. I see that one's running, so I could stop it. Container stop, and then I would want to, since I didn't give this a name that automatically assigned me a name, modest or, which is a great name. We could stop that, and then whenever this stops, we would be able to see in our containers that one was also removed because we added this --rm flag, which means that after we stop a container, so if I do docker container ls-a now, it's no longer there. So that makes it a little bit easier, so you don't have to go back and clean up after yourself non-stop. And also, like, we're not going to cover it in this, but like I said with NodeMon, with doing a hot reload, you'd be like, well, that'd be sweet if I could do that with my Docker container and not have to, like, you know, every single time I were to make a change in this folder. For example, like, if we were to run this again really quick, let's just do that. So we can check this out. So it says intro to Docker. You just created a node, express, web application with Docker. I totally stole this from AWS. But let's say we wanted to change this to where it said from Orlando, something like that. And then I wanted to do a docker ps, and I wanted to see that ID, or I have a name for it actually with this command. So I could go docker container stop, docker container stop Orlando node app. Whenever this stops and I restarted it, it wouldn't show this from Orlando. I would have to rebuild this entire image and then run it again. Now you can set it up to where you do like those hot reloads and stuff. It's a bit more in depth. We're not going to do that, but I just want to like let you know, like be aware that it's available. But so I would have to run a Docker what is the command? Build, yeah. And then I would have to run it again. I've got to go delete this. This is a good use case to show why you'd want to put that --rm flag. And then I can go up, run that again. Now I can see the from Orlando. Cool. And then again, Docker PS, grab that, where I know the name, Docker container, stop. Then I'll stop it. So let's use some Docker Hub and put it up in Docker Hub and talk about that really quickly, and that will help us like segue into using some AWS stuff. Any questions before we do that? Still know what Docker Hub is? Cool. All right, so let's see. All right, so I want to tag my image. So if whenever you're using Docker Hub, go here to Docker Hub. See how it says Austin Lovelace and then /, and then this is my image name. So this is how we need to tag our image to be able to push it to the correct registry or repository. So what I could do is run Docker, what is it? Image --help. So tag, so Docker image tag, I think it's the name of your container. I could have this backwards. And then the name of your tag, so it's gonna be Austin Lovelace / Docker on AWS. Let's see. Docker images. Okay, I think I got that right. So then we can do Docker push Austin Lovelace / Docker on AWS. Ooh, I was worried I didn't think that would work. Okay.
Because you already signed into Docker Dash.
Oh yeah, I completely forgot because I don't usually have to sign in. So yeah, you would do a Docker login if you wanted to sign in to your Docker Hub account through the CLI. Dude, good catch. Okay, so I'm bringing you around with me. So this already had my credentials here, but if I didn't have it, it would ask me to put in my username and my password, and then it would authenticate me, and I could push it up. So when I come up here, there it is. There's my Docker on AWS. Okay, sweet. So let's use some AWS stuff. So let's go back to doing some slides, because slides are great. Not really, but they help. So Docker on AWS, we have a couple of services we're going to use. So we want to use ECS, which is going to be our Docker orchestration tool, which basically means that we're able to control our different Docker containers with this service. It allows us to easily use the CLI or the console to be able to manipulate and change and update tasks and services, which is specific jargon for ECS to use our Docker container. And then ECR, just think Docker Hub, but for AWS for the most part. And then Fargate. So Fargate's pretty awesome. It's a relatively new tool, and it makes it a bit easier for purposes of this class for us to use. And so traditionally you would have servers, and this still runs on servers. It's serverless, but there's still a server that executes your code. But traditionally whenever you're using containers, you would have a fleet of EC2 instances that are ran. Set up an auto-scaling group, set a bunch of policies, do the traditional architectural design for that. But with Fargate, basically I can do that same exact thing, but Fargate's gonna like scale for me automatically and manage those resources and underlying infrastructure for me, similar to if you had like Lambda. This is like the Lambda equivalent, but for containers. And I'm a huge serverless fan. I talk about serverless all the time, and so I'm always like ready to use serverless resources if I'm able to. And this makes it a lot easier because I don't have to worry about, like, let's say I had like a super crazy traffic spike and I had like a bunch of instances that were like spun up. I had like extra 10 instances to keep our math easy. And so I have like 20 instances running total now. And then I had like a big dip after a couple of hours. I say we, or like after a day, say we had like a big Black Friday sale and we're like this, I don't know, t-shirt selling company or something. And so we had this huge spike and we had an extra 10 resources spin up, and then we have a dip in our traffic. We still have those resources up until they, like, the CPU goes down, everything goes down. It takes a minute for those to deprovision. So we're getting charged while that's still running. Whereas with Fargate, it's easier for it to like meet the amount of like requests you have coming in and scale with that, so you're paying for only what is being called on. So that way it's like easier to maintain your infrastructure, so you don't have to worry about like you didn't have enough resources, or it's easier to like be more cost effective. You know, there's edge cases and stuff, but generally speaking, it would help you mitigate costs by able to have only the amount of resources you need per the amount of requests you have.
With Fargate, can you set limits on how much it will scale?
Yeah, I think so. I don't know, let's see. Can you limit Fargate? I don't know. I think that there are limits that you could add. I know that there's limits that AWS has, like the amount of concurrency that they allow, but I'm not 100% sure. We'll go through the console and we'll look at it. Like you're saying, like if I had a bunch of resources coming in and I wanted to throttle those amount of requests, and like say I don't want to go over that because that's too many requests and we want to like not.
You don't want to incur into a very large bill for a hacker attack, for example.
Right. Yeah. No, you can set up throttling and stuff, and also like if you had like an API and you were using Fargate for API, you can also set up like API gateway in front of that and set throttling limits there on that level as well, so that before you even got to your resource, you could stop it before it even got there, and also chart. Yeah.
Could you use CloudWatch for that too?
For throttling, no, I don't think so. I think you would be able to use. Probably in the sense of if you had an alarm based on the amount of like CPU or memory or whatever metric you're using, and then you had a Lambda function that was able to like be ran after that and be triggered by your CloudWatch. But like CloudWatch itself wouldn't like throttle your requests. Yeah, I'm sure there's like a way that you could set it up with like a Lambda function to do that. But yeah, I'm pretty sure you can throttle it. I just don't have like 100% guaranteed. Yes, here's the documentation answer for you. So ECS we talked about. I jump ahead of my slides because I don't know if you hear my sarcasm. I'm not a big fan of slides. Here's the definition of Fargate. Oh, it also supports Kubernetes now, which is pretty awesome. Serverless Kubernetes. Yeah, if you guys want to read that, leave it up there for you. But basically, Fargate's where we can run serverless containers and serverless Kubernetes clusters and such. And then the AWS CLI. So if you don't have this installed, I'm not going to go through installing it, but AWS CLI install. You know, there's different versions of it. I installed version 2 recently, but I have been using version 1. Version 2 just, you know, you have to put AWS 2, so I'm lazy and use version 1. I don't have like any good reasons to use version 2 yet. It's pretty new and there's like a couple of features that it doesn't support, but yeah, so you can go in here and see the installation instructions right here. So check that out. So what we're gonna do initially is we're gonna set up our AWS CLI if you do have it installed. I'm gonna do something that I highly recommend you don't do, but we're gonna keep it very basic for the purposes of this and not have to talk about so many different resources. One of the problems with AWS, with teaching these classes, is we have like tons of different resources out there, and so I say we as though I work for them. They have tons of different resources out there, and they all connect together, and so we have to have multiple different resources that we're using to create our environment. And so basically right now we have to use IAM, which is the service for identity and access management, which is going to give us the ability to sign in to our AWS CLI, similar to how we did with the Docker CLI, to use Docker Hub, and this will allow us to use AWS to build our resource, because we're going to build everything through the CLI. The reason for that is, one, I like to do things that allow us to have automation, and using the CLI is one form of automation, because this is something that is pretty much concrete every single time. Whereas if we were clicking through the console, you may click something different, and there's more room for error, and I wouldn't want to go debug everybody's different environments and stuff. Also, we could use CloudFormation and spin up the environment like that, but we're using the CLI today. And in the future, if you're in a production environment at work, I would definitely recommend using CloudFormation or infrastructure as code in general. So what I'm going to do now is create a role, and I'm going to not create a role, my bad. I'm going to create a user. So I'm going to go to the IAM dashboard, go to users, go to add user, give my user a name. You could call it ECS users, what I had mine called. I'm going to go ahead and do that since I'm actually going to create this user, but okay, we'll call it ECS Orlando user. And we're going to give it programmatic access. Spelled Orlando. So this gives us an access key and a secret access key. And so we'll use this for a command we're going to run called AWS configure. And this is going to ask us for an access key and a secret access key and our region and default output. So we're going to get that from creating this user here. And then I'm going to click over to this tab where it says attach existing policies. Again, highly recommend not doing this in production environments, but for test, we're just going to give it admin access, keep it super simple. We're not going to go super in detail with IAM. Tried it before, it gets I don't know, I don't have, yeah. You could go granular, and we could use ECS, and then you need to have an IAM policy, but we would spend a lot of time going through and grabbing all the specific ones. So we'll just do that, hit next to review, create user. So then I have this access key and the secret access key. So now I would copy these. I'm not going to show you my access key, but I'm going to copy these and put them into my terminal when I run this command. So basically I would just copy those, paste it, and then my region I would want to make as US East 1. So mine's already defaulted to that. But we're going to use US East 1 for all of our resources that we create today, which is in North Virginia. So you could create your AWS CLI and get that configured. Go ahead and delete my user. Does that kind of make sense? Or basically creating credentials. We more or less gave that person God mode, but they have access to our entire account, which is not something that I would recommend, but keeping it really basic, and we'll delete everything after this. Don't share anybody your stuff, don't post it on GitHub, should be okay. But we configure a CLI, now we're going to create an ECS cluster, and we're going to deploy our node application. So with that, I've got this tutorial here, and like I said, I don't remember all of my commands. So one of the commands we need to do is, and here you go, here's what it would look like if you were to fill everything out with AWS configure. But so we need to create an ECS cluster. So what I'm going to do is run this command here. So this is AWS ECS create cluster and then a cluster name. So I could do AWS ECS. So I'm saying AWS, we're using that command line, and then ECS is the resource you're using within AWS. And then we're going to run the create cluster command within the subcommand, and then we're going to pass it a flag of cluster-name, and then we're going to call that Docker on AWS. Oops. And then we should get an output similar to this. Cool, so now we've got a cluster created, so we want to see what that would look like if we went to the console. Yeah. Yeah, awesome question. So an ECS cluster, it stands for Elastic Container Service. So this cluster is going to be what's like housing our different like containers. And so what we're going to do is we're going to define a task. And this task is going to say, like right now we have this task to show you what a task definition would look like. So we have this task right here, and this is going to set up like where I have an execution role, stuff like that, but we're basically going to define an image that we're going to put into like a Elastic Container Registry, similar to Docker Hub. So we put that Docker Hub image here, basically, we reference that, and then we set up these port mappings, which is to say that this Docker container needs to be open and listening on port 80. And then we're going to put it on Fargate, which is our serverless container resource. The alternative would have been EC2. And then we're giving it amount of CPU and memory. I think these are the defaults you have to have whenever using Fargate. Don't quote me on that, but I believe that is the case. And so with this cluster, we can run multiple containers on this cluster, and we can just open up different ports for different containers. And so we're going to be running one container on this cluster that's going to be running one Fargate service. And basically this whole entire tool right here is an orchestration tool that's going to allow us to, you know, manage all of our different clusters within AWS. So like,
What was the question again?
why would you want to, the question was, why would you want to create a cluster of containers, correct? So whenever you have like this like cluster, this is like just the more or less like kind of terminology that we have here for ECS, but this is going to be where we can run multiple different containers. It's because we have like that one server, right? That one piece of hardware. We've got multiple different like container, like little like resources, little blocks you could think of. You have like a grid, and you have like 6 pieces on this grid. And we're given this little box here, and a little box here, and a little box here. So then we can set up a microservices architecture and say that we have an application here, 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 you know, and fill out these different boxes. It's also filled up with other AWS users and stuff, and this cluster is just a way where we can manage all of that. Does that kind of make sense? Do you have any input with that?
This is all why I'm here.
Oh, okay. I was hoping we could bake some more of that cake. Joking.
You're starting to make it. There you go.
Okay, cool. Any other questions? Okay. Okay, so we could like list our different containers. We could do AWS ECS list containers. Containers. I think I spelled something wrong. List clusters, there we go. AWS ECS list clusters. Alright, so we can see we've got that one cluster, and then this says cluster ARNs, that stands for access resource name number. I always get them confused. And so this is basically like a unique identifier for our resource. So then, you know, if you wanted to delete your cluster, you could do like that. We're going to delete everything through the console. But, so cool. This is to push an image to ECR. Instead of running through these commands, I think it'd be more beneficial if we used the CLI for this, just because they have all the commands right there. And it's really cool to like see how this is done. So let's not create our own repository. Let's build one through the command line, and then we'll push it. And I'm skipping this stage for a reason, because we're about to run this in a second. But so what we could do is run this, and I would keep the repository name the same because it's utilized in other files that we need. So this command is going to create us a repository, which is similar to how we created the Docker Hub repository. Gives us some information about it. So if we went back here, we could see this repo, and I could click into it. And then it says view push commands. So it gives me a list of like super easy to use 4 commands. I just copy and paste. It's got some for Windows as well that you could use. So I'll just copy that, throw it in there, bam. So this is going to be how I'm able to get into the ECR repository to get credentials for that to be able to push on my image, similar to Docker Hub. This will build our image and give it the proper name that we need. So this naming, again, this is the name of our, let's go back. This is the name of our repository. And so how we wanted to name our Docker Hub image the same name as our username and then the slash, we want to do the same for this. And so we built our image, and now we want to tag it. I think I spoke a little bit too quickly. So this is actually what that is. So this right here is my account ID, and then this .dirs, all this stuff. So this is the URL, which is right here. This is what we're tagging it with, so that we know exactly what URL we're pushing our repository to. So this way I can tag it and be like, okay, this is the same thing as saying right here, this is Austin Lovelace, is Docker repository, Elastic Container Repository.
If you list your local images,
Yeah. Oh yeah. So then I would
show
have,
local tags.
yeah, it would show me that tag right here, or this one I guess is one I just created.
So you build it like you did before locally, you just tag it to the AWS container and then you push it.
Right. Yeah, it's the same thing, except now we're giving it the name of our the URL for our ECR registry, and then the name of our container.
So Docker push will always require the name or the address of the registry
Yeah.
unless, and if you don't specify it, it assumes it's Docker Hub.
Well, if I tried to push that, well, it's gonna work. So if I tried to push like this, for example, let's see what would happen. Oh, well, that one's connected. Actually, let's see what happens. Okay, so yeah, it says requested access to the resources denied. So this isn't gonna,
So it's saying
this is
Docker
referencing,
IO.
yeah, this is referencing like an image that I have already there. But if it might be because I'm not logged in, let's see. Okay, so then if I did Docker image tag Docker on AWS, and then Austin Lovelace. And then so now it's going to be called Docker images, and then if I did Docker push, and then this one's going to work. So yeah, you have to name it or you'll get that
You
error.
have 4 tags right now, all pointing to the same image.
Yeah.
So you can push the same image to multiple registries or different.
Yeah, so like they're kind of like clones of the same image. And we understand that, but I don't know if Docker understands that. So this is like these different tags, like this is considered like different images, and so this has different credentials to go to different places. Like I can't name by this name and push that to AWS.
Well,
I can only push.
They all have the same image, I think, so
Okay, so it's just different tags,
It's the
yeah.
same image, it has the same image ID.
they're just pointing.
Right. Okay, so then if I wanted to push this image, I would need to paste that, and then I would be able to push this to, it refers to this repository, and, you know, hopefully in theory, I'll get it up here in a second.
Now when you pushed it to Docker Hub, the last 3 layers didn't get pushed because it was built on top of something else.
What are you talking about? Oh, this layer already exists?
No, way back up when your first push.
This?
Nope, the very first push, all the way back. I don't know how far you have to go. This
I don't
is
know.
before all the Amazon stuff.
Oh, I don't remember. Like we did it a while ago, right?
Yeah.
I'm not sure. Well, what was the command that popped up?
It wasn't a command, it was just the
That
last
output?
3 layers, it was like all linking something.
I honestly,
Like layer link exists or something.
like this says layer already exists. I don't know. I honestly don't remember what you're talking about. We could talk about it after this. I honestly,
Yeah.
we'll have to go back through. I don't remember. But here, we can see that image is now pushed up here. We have this image URL. And so basically if I wanted to pull this image and run it like let's say we had like a dev team set up and we had our images up here, then I could have like give IAM access to a user that would be able to come on here, grab this URL, do a Docker pull, and then run that on their local machine, and then they'd be able to run that image that we have in production. Does that make sense?
Assuming they have permission to get to your
Right.
registry.
Right. Like I would have to have like a user defined an IAM, and then give them like access to log into the console and stuff, and then or like give them programmatic access, and then they would have to then do it. Yeah.
Could you make this public,
This?
this image public?
No. This is going to be like linked to just my AWS account.
Because if you could make it public, then they wouldn't have to log in.
Yeah, I mean, I can make it public as in like pushing it to the Docker registry, but I wouldn't want to like make this public because then somebody could like, potentially get into the shell of my environment and then see all my code, and maybe I don't want people to see all my code, so I would want to like probably keep this more locked down because this would be the same as if I had like my GitHub
I know that that's a
repository.
requirement right now, but I'm not just saying if this image repository allows you to have public images.
No, you would have to have a user within AWS and give them credentials, and then they would have access to it. And I think that that's a good reason or a good thing because you could run into like security issues, and you don't want to have people have access to your code and stuff. If you wanted to have a public image, then I would suggest like it just be something open source that isn't sensitive data, and put it on Docker Hub. So then the last couple of things we need to do, so we pushed it, had our stuff up there, we could run this command. I'm going to be lazy and copy it, but we could list our different images and see what images are in our repository. And then we'll be able to see like this one image ID that's there that we just pushed up. So then we need to do a couple of things. We need to create an ECS execution role. Then this is going to be attached to our, our ECS cluster. So like I said, you have tasks that run within ECS. And these different tasks do things like use this image and create our new container and start a new container up. And then we have a service that calls a task, and then the service starts a task, and we'll do all of that. So before we do that, we need to create a user, and we're going to do this all programmatically because I've got the code right here, and it's just like going to assume a role, and we're going to attach a role to this to give us ECS execution permissions. So the command for that is right here. So we go to the repo, we're going to create an IAM role, we're going to give it a role name of ECS task execution. It's going to assume this policy document that we have defined right here. So I can go paste that in. And then we see the output says like, cool, we made that role. And then we want to attach a policy, and we want to attach a role that is managed, or a policy that's managed by AWS, and it's going to be this Amazon ECS execution role policy. And if we wanted to see what that was, we could go into IAM just for like future reference if you wanted to see like what policies we're using and stuff like that. What is the name of that? Paste that in there. Click in here, we could be like, okay, cool, what does this do? So this is going to give us access to ECR so that this way we can pull down that image, basically. And this will allow our cluster to access ECR to pull that image to run that container. So, copy that command again. Okay, there we go. So I'm going to attach that policy. Great, so now that policy is attached. So then what we need to do is we have this output right here of this ARN. This is our task execution role ARN, which is like that unique identifier for that IAM policy. This is specific to your account. And then we have this node task definition JSON. So what we need to do is get rid of these X's and paste in that. And then this X right here, both the X's honestly are both the same thing. It's your account number. So then you can just paste that, and now this file is ready to be ran. So this now has our image. If you named it all the same, otherwise you need to update these names and whatnot, but you just needed to put your account ID in there. So now we can run this task, we can create this task. So to register a task, we have this command that we can run, and this is going to register a task definition, which is going to be like saying we want to have this container ran with this port allowed and this IAM policy attached. And so we'll just copy that, and then we'll have this file that it references for that task definition. And it's all like JSON format. So then right here we have some information. This like basically tells us like what our task definition is, you know, what attributes it has, family it's attached to, compatibilities, ECR and Fargate. So we've got Fargate there, how much CPU, how much memory, you know, our port mappings, our image that we're using, and then right down here is this revision, and I've got revision 6. For you guys, it should be revision number 1. I've ran through this a couple times to make sure it all worked, so I've got 6 different versions. Is basically what this is. So if I like updated this and pushed it again, it'd be reversion 7, reversion 8, and etc. So I'm going to need to update a command earlier, and what I'm going to be doing is I'll like skip to that. This command is like really big and bulky. To kind of break it up, if you look right here, yeah, right here, this Fargate task 1, right here, this family Fargate task, Node.js Fargate task, Node.js Fargate task, revision is right here, so mine's gonna have to change to 6. So whenever you see me do that earlier, or later, that's what I'm doing. So then, last like 2 or 3 commands before we can get this thing running is we need to create a security group, which is a security group is basically just a way that we can like keep security within our like network and stuff. And so we're basically going to open up port 80 to allow public access to port 80 to come in and view our website. So we're going to grab this command. This is going to create a security group, give it a security group name of ECS security group, and a little description to say what it does. We can run that. And it'll give us a security group ID. We need to be aware of this ID. We're going to use it in a couple of other commands. So what we need to do now is add that ingress rule to allow access to the world for port 80. So what this says is we want to take that security group that we just created and say, hey, I want everybody to be able to access my application through port 80. So I'll paste that in here, and then I need to update that security group ID. So I could just copy that, paste it, bam, so that should be good to go. And then 2 more commands that we need to run is we need to, and this gets a bit more into networking and stuff, but in order to get our application running on Fargate, we need to set this up. So what we have here is we're going to describe our subnets. So basically what this does is our subnets are like little resources within our data center, basically. So not to get super deep into networking, but you have like a data center, which what we call is a VPC, virtual private cloud, which is a in-cloud data center, a virtual data center. And you have subnets within that, and the subnet is attached to every availability zone. This is going to get like, this is one of those things that there's so many different things that AWS has, you have to explain, and it gets way deep into the weeds. So basically in AWS, their terminology, you have a region, and a region is like what we use for US East 1, which is in North Virginia. North Virginia has multiple availability zones within that region. They have 6, and they go US East 1, -A, or US East 1A, B, C, D, E, F, however many that is to get to 6. And then within that we have a subnet per region, and so we're going to take that subnet now, we're going to describe it, and this is going to output all of our different subnets. We're going to have a subnet ARN and this subnet ID, And what we need to do basically is we're just going to copy one to keep this a bit more simple and make this command a little bit shorter. We're going to, for APS or AWS VPC configuration, we need to open up so that this application runs on a specific subnet. Ooh, any questions on that? Probably a lot. Yeah, that's a bit more networking stuff. Like, we could just act like this is magic and just roll through it. I think that's probably the easiest way for purposes of this, because this is like a whole another 2-hour topic to talk about networking. So, one important thing to note here, though, is this assign public IP. Enable that. By default, that is not enabled. Whenever I was creating this course, it took me a while to realize that that wasn't enabled, and I was having a hard time getting this configured and started without that. So that's why this is enabled, so that we have a public IP for us to be able to view our website. So what I'm going to do now is I deleted all those X's and stuff, and I'm going to paste in my security group that we created a second ago, and I'm going to delete these subnets. Where did my subnet command go? I think I ran it the other terminal. I'm going to delete all these. I'm just going to put it in one. We don't need to be highly available. Alright, so we'll just take this one, and you can just take this whenever you run this command. You can see this is US East 1. There's 6 of these. Here, look, they have US East 1E, US East 1C, and so you can tell the different ones here. So we're going to use US East 1A, and I'm going to paste that in here. And then I need to update this task revision number.
We have an extra double quote in the subnet.
Oh, dude, thank you. That would have been a catastrophe. It might have actually been, I don't know. We could have just gotten a syntax error, could have like deployed and broke. So I just had an extra one that I copied.
Yeah, the one you pasted in at the end of the sentence.
Right, okay, I see it. Cool, cool. Alright. Cool. In theory, this works. So, this is giving us information about what the service was that we just ran. So the service is going to, if we look at this command, it's going to create a service. We're going to declare what cluster we're doing it on, which is at Docker on AWS cluster. We're giving it a name, which is Node.js service. We're going to take the task that we had defined earlier, which is that Node Fargate task, whichever revision. Yours is probably going to be 1, mine's 6. How many different Fargate instances we want to be running? We're just going to be running 1. And then network configuration is black magic. And then the assign public IP is enabled, and our launch type is going to be Fargate so that we can run serverless containers. So, back to our application, we could see that we have this service right here. This is within our clusters on our ECS, going to Docker on AWS. See our service name, say it's active. We got our task definition, desired count, and running count. That means we were successful. So to get to our public IP address, we just go to tasks, see our task ID, the task definition, which before we see that it's running, we could go here, and you could build all this in the console as well, but it's easier, or I think it's like more maintainable if you do it through the command line or through infrastructure as code. So here we can see this is like the full built version of what we had ran earlier. And so this is our execution ARN, our host port mappings, our image, you know, all that information, all right here, easily able to see more information about our tasks and stuff. So I go back to my cluster, go to my tasks, go to my task that's running. I've got this public IP. I can see our application. So that's how you run a Node application and ECS. So, any questions on any of that stuff we did? Yeah.
What's the difference between task and task definition?
So the task definition is just defining our task, and the task is like the actual, the thing that's going to be executed. Like if you had like our Docker container or our Docker file was our blueprints for our image. Is the same as like a task definition. It's just the JSON, like the instructions to create the task.
So you can have multiple tasks, right? One task definition
So if you had one task definition, that would be you would run one task with that.
Okay, so you cannot run multiple tasks with one task definition.
You can run multiple tasks with, I think, a single service, right? And you. So you have.
What's an example of like how it would be structured?
What do you mean?
Like if you have an application, let's say web tier application tier and database server, and you want to input everything like all three container images into one task definition, can you do that? Or you have to create three task definitions?
You create 3 tasks.
You create 3 tasks?
Yeah, no, I actually think I might be wrong. I think it might be like one service for one task, and a service will run a task, but a task will create a container that will run on your cluster. So you have like a service, and the service is defined within this cluster, and you have this task definition, which is this like this JSON file that says, hey, I want to open up this port, and I want to run this image, and I want to put this much memory and this much CPU to it. And then that service runs that task, and that creates your container on your cluster. Does that make sense? Yeah.
What do you think is best practice in terms of performance when it comes to like running apps with Fargate? Is there any spin up time that you notice with
I mean, I guess it depends on like the size of your application, you know, like, I mean, I think our size is 82 megabytes, so it's a pretty small app, you know. And, you know, like if you went to Docker Hub, and we went, just to show you really quick, Node.js, Node, Docker's official Node image. Oh. So then right here, they have like these different like dash stretch, dash alpine and things. The dash alpine is a really slim, like smaller version of the image, which would make like your package a lot smaller. And like down here, they have like quick references, you know, like to say and stuff.
Have you seen the size of that generally relate to building performance in the browser?
I mean, if I were running if I were actually like trying to use Fargate or like build an application, like a modern application, I would never run unless I had to do server-side running for whatever reason, I wouldn't run what's it called? Like a front-end app in a container or anything like that. So I don't know like how your load time would be in the browser like that. I mean, if I were to do that, I would use like S3 or something, but as far as like speed and stuff, I mean, I don't have like a clear answer with how long it takes. I mean, we had that started in like pretty damn fast, so it is pretty fast, and it's faster than if you were to use an EC2 instance, because you're not like using VMs and having that like guest OS and stuff we were talking about earlier. Yeah, I have like a number of it would take you this long or this long. I think it all vary. I don't have a lot of experience deploying like giant applications like that.
Yeah.
Yeah, no, I mean, that's a good question. Any other questions and stuff? Any other like topics or things you want to talk about, or cool AWS stuff that doesn't relate to Docker at all that maybe you guys want to talk about?
I just have a question. So this might be a little beyond me with the clusters. So how does Docker relate to EC2? So can you surpass like making a cluster and just spin up an instance and run an application on an EC2 instance?
Yeah.
Is it just cheaper to use ECS over an EC2 instance? Is that why you use ECS?
Well, why would I use ECS versus EC2? Well, that was like part of the thing that we were talking about earlier with like, you know, microservices architecture. And okay, so to backpedal a little bit, trying to figure out the best way to answer this. I like tend to ramble sometimes. So at least with AWS best practices, like whenever you build an application from the get-go, you want to start out like building an application in serverless. And then if serverless like doesn't meet your needs, or you need to like go beyond that scale, or it's too costly or whatever, serverless isn't the right answer, then you want to move to Fargates, maybe like a serverless, or not Fargate, to containers, maybe like Fargate. And then Fargate didn't work, maybe then you could run container with EC2, and then go to just regular traditional server infrastructure where you just had EC2 instances. But like the reason why we're trying to like move away from that is because it's like easier to make a monolith instead of like breaking things in different components. And you could do that with EC2, but then you're having to manage multiple different pipelines and multiple different deployments. Whereas with this, we just create a different task. We have different image, different task, different port, and we're done. It's just easier to maintain. Yeah. What about something else? That's all I have for like the overall course and stuff. But, and by the way, like if you guys weren't able to follow along or I talked really fast or whatever, this is all recorded and live streamed right now, so it'll be on YouTube and yeah, we'll like send out an email, stuff like that. You can follow along and watch it afterwards. Sweet. Well, if there's no other questions, I think it's beer time.